All right, welcome to Earth Science, everybody. It is time for the relative humidity and dewpoint lab. So I got a bunch of stuff out. So we're going to pause and go to a couple different places in the house here to think about different levels of humidity. So first, let's go back to the basics here. I know you've done a bunch of these. What is dew point? So you've been calculating these like crazy since before holiday break and after, right? What is it though? What do we remember what it actually means? So what is dew point? And the way we're going to demonstrate it is to look for something happening on the outside of this can. Now this would work a lot better if it was summer. Picture a soda can in the middle of summer on a hot day outside. What happens all over the outside of the can? Dew point is the special name for the specific temperature. It's a number. So it's the temperature at which condensation, I'm going to put that in all caps, occurs. Temperature at which condensation occurs. Don't blow this up a little bit. So what temperature do you have to get to? Now this is different every day, and if this lab goes according to plan, this is going to be different on this floor of my house and down in the basement. We'll talk about that in a few minutes. So I can't say that the temperature is this number. It's whatever on that given day, what temperature you've got to get to for condensation to occur. So with the canned example, if you remember, if you thought of that, what happens in the summertime is that you get all those like little water droplets on the outside, right? What are those? And it's the same thing with dew on the grass. If you wake up early and go out in the grass and see dew there, what happened is that the temperature, because the soda was refrigerated, the temperature got cool enough right next to the can, the air that was directly in contact with the can. That air got cool enough that you got down to the point at which condensation, which is a change from a gas to a liquid. There's some water vapor between my hands right now. There's water in the gas form. Condensation is when does that go from a gas to a liquid? And it's got to get cold for that to happen. Condensation happens on cold things. Any cold things you can think of in the summer. It'll happen on it'll happen on toilets. If you have cold water that comes into your house, the toilet gets cold, the ceramic gets cold, and it gets condensation on it. It happens on the air conditioning units of cars. You'll see water dripping out of your car when you stop if you're running the AC. Any cold things you can think of in the summertime, that'll happen. So the premise of this lab would actually work a lot better in the summer. But the premise of this lab is, what if we go and chuck ice cubes into water? And I've got this all here. And we'll see what happens. When can we get some condensation on the outside? Okay. So of course, when this is a normal year again, we'll be doing this in class, and you'll be chucking ice cubes in there, and you got thermometers and room temperature water. In fact, let's go ahead and do that. We'll put some room temperature water in here. And I'll drop ice cubes in here bit by bit by bits, and I'll be monitoring the temperature as we go. And we'll see at what point do we get condensation on the outside. This aluminum conducts pretty well. So the water and the metal should be about the same temperature. So what do I have to get the temperature to in this room to get condensation to occur? And that's the dew point, right? So we used to do this over 2 days, and I would try to bring humidifiers into the room and make it more humid, which didn't work anyway. This is probably going to work better. So it's not going to look exactly like this. The way we're going to say this is all going to be one day anyway. So we'll say like experiment one. It's probably a better way to say it. But what I'll have you right in this one is upstairs. So we're on the second floor of my house. We're on the first floor of my house, I guess, above the basement. Let's use the text box. And then we'll say for this one, how is it different when we go down in the basement? I'll press pause, walk down to the basement, get set up down there, and basically do the same thing. Okay. So if you were listening to that last bit and you're on YouTube, rewind a little bit if you missed it. That's how this experiment shows you. Okay. That whole thing I said about what we're looking for. So keep this video from getting too long, what I think I'm going to do, and so I can cough a little bit here, is pause it and do this part, because I think it might take a little while. And that's because we heat with wood over there in the other room, and it's very, very dry. If you know anything about heating with wood, it gets very dry in the house. In fact, all houses get pretty hot, pretty dry when you heat them. And we're going to have to answer that later in this lab right here. Why does it get so dry inside in the wintertime? So what I think I'll do is I'll pause. I'll come back up here, and we'll see what we got. And then we'll go downstairs and try it again. It should work a little better downstairs. So I'll be back in just a moment. All right, I'm back, and I got a little condensation on there. I'm doubting you can see it on the camera, but let's see if I scrape. You can see it. There you go. So I got a little bit of condensation on the outside at a temperature of 9 degrees. So that's going to be our answer in here, and that is in Celsius. All right, so what does that mean? And again, going back to how this shows you the dew points, this can got cold enough that the air next to it that has a little bit of water in it, that water was forced to condense because I cooled that air to the dew point with this cold can of water. All right, I'm going to get rid of my ice and my water. Warm this up a little bit. And we'll try it downstairs. Now, this part of the house is like, I think from the 60s or something, but the old part of the house over there where we're going to go down in the basement, this is a really old house. This was like mid 1800s. The original house was built. So it's one of those basements that some of you might be familiar with where there's exposed dirt, soil. Some things are held up with logs. It's quite old. Hopefully still standing for a few more years. But because it's one of these old basements, what happens is if we get a pretty good snow melt or a pretty good rain, it can get pretty damp down there. So it's definitely a damp basement. Now we've got a dehumidifier running, and I think I'll show that just to say, here's how this thing works. But my guess would be that the humidity is going to be higher. I think it might be important to note, because the temperature could be different down there, what the room temp is. So I'm saying through this experiment, 9 degrees C was our dew point, DP. That was the temperature I had to cool that can down to get to the dew point. Whether this ends up being important or not, I think it's important to note. I think it might be important to note room temperature. So room temperature right now, I'm just going to check a couple thermometers. Yeah, they're all agreeing. Room temp is 18. Okay, so we've got a room temperature of 18, and I had to cool that down to 9 to get to the dew point. This is in Celsius, of course, if you want to know what those are in Fahrenheit. You guys now know how to convert. So I'm going to press pause, go down to the basement, and we're going to run the whole experiment over again and see if there's any difference. See you in a minute. All right, so here we are. Creepy looking basement. It is creepy, but it doesn't look it's not as creepy as it looks on this camera with the poor lighting. But you get the premise. Here's a little Blair Witch. Here I am, perfectly safe. Now it is colder down here too. So this thermometer is telling me that we're down to about 13 degrees. So it's a little colder down here. Definitely damp. There's the dehumidifier, and it wasn't working well. There's water on the ground right next to it. It was at an angle or something. So we'll fix that. But we definitely should have a more humid situation here. So I'm going to basically run the same experiment. There's our can and my little bowl of ice. I'll do the same thing. Did I fill it with water? I did. That's good news. I'll fill it with water, do the same thing, and we'll see what the dew point is down here where the temperature is a little colder. Yeah, staying around 12. So I'll do that. Be right back. All right, so I got there. I got a little condensation. I doubt in this light you're going to be able to see it. But yeah, got it for sure. And it was right around 8 degrees when it happened. All right, so 8 degrees would be the dew point down here in the basement. As I'm crouching and scrambling, there's low ceilings down here too, so I gotta like crouch and scramble here. Not the ideal setting. So down here, 8 degrees C was our dew point, but the big difference is going to be that we started a lot colder. It was only about 12 degrees down here. So I think I'll talk about that when I get back upstairs because I don't know, it's just better up there, yeah. And then we'll talk about this dehumidifier too. We got to do part 2 of the experiment then. Hang tight, doing good. Thank you. All right, back upstairs. Here we go. So the big difference was that down there, our room temp was, I believe I said it was about 12. So one of the major principles of this lab, and one of the things that's going to help you answer this this fire in the house question later that is difficult. It traditionally stumps people. One of the big ideas is that it's the difference between the two that really tell you what's going on humidity wise. Up here, it's 18 degrees, and I had to bring it down by 9 degrees to 9 degrees to get condensation. Down in the basement, I was at 12. I only had to bring it down by 4 degrees to get to condensation. That indicates, once you learn your stuff here, that indicates to anybody that knows anything about humidity that the basement is more humid than it is upstairs, which you would also like just detect. You would know that if you walked into my house and then you walked down in the basement, you'd say, it's more humid down here. Just you would feel it, right? Well, here's the numbers to go along with that feeling. I only had to cool it down by 4 degrees to get condensation, whereas I had to cool it down by 9 degrees to get condensation up here. Okay. So that brings us to part 2 of the lab. So we would do this as like little miniature sections of multiple days for like a week and then wrap it all up at the end of the week, along with other lessons. You guys are just doing it all in one big chunk, but that would be no big deal. So what will be the difference in what happens to wet bulb and dry bulb on humid days versus dry days? So again, we're going to get to do that by being upstairs for a dry day and downstairs for a humid day. So I guess we should change that right now, right? This is upstairs. Don't worry about the humidifier thing. That was just an experiment we tried last year, hauling humidifiers into the room. And this is basement. Our dry bulb temperatures are unlikely to have changed. No, they didn't, because this has all been over the course of about 10 minutes here. So we're still going to say, I mean, I'll check it when we get down there, but it's unlikely that it changed. So our dry bulb upstairs still 18. Should be degrees C, but it's such a pain to do labels in Cami here, so we're not going to worry about it. And downstairs was 12. All right, so what we're going to do is set up a Sling Cyclometer. So what I did was I just took one of these regular classroom thermometers, kind of bent back the metal, cut off a piece of one of my son's old whoobies, and rubber banded it around the end. So I've got a piece of cotton fabric, essentially, on the end, held onto the end. That's going to be our wet bulb. To make it a wet bulb, lo and behold, you get it wet. And here's where we're going to remember the idea that, hey, when I get out of the shower, lake, pond, pool, rainstorm, whatever, when I feel that water evaporate off my skin, I feel chilly. We know that when water evaporates, temperature drops. Now, if you've got a real deal one of these things and not a bootleg manufactured one during a COVID year, this is what it looks like. It's got a handle. You really should sling the dry bulb with it, but I'm ignoring that part. And because the important part really is the wet bulb. So I'm imitating that by just taking this thermometer. I don't have a handle or a swivel. I'm just going to whip it around with my arm, hopefully not break it, and see what we get into. So I'm doing this to speed up the evaporation happening off the end of that wet bulb. Let's see. All right, we got a wet bulb temp of 14 degrees C. Yep. So up here, went from 18 and dropped down to 14. What do you expect to happen when we go back down to the basement and do this again? Let me put it back in the room temperature water. Let that soak and normalize again. I'm going to leave these two to you. This is going to be your job. You've done a bunch of these. What is the dew point and relative humidity in those conditions? Which means you're going to have to go back to this chart from the Earth Science reference tables and solve that. I'm going to do it right now because it'd be interesting to know how close the other experiment came to it. Interesting. Not exactly the same, but that's okay. All right, let's pause. Go back down to the basement. You guys are getting there. Hang tight. Appreciate your patience and your hard work. Okay. So I got a couple of dry bulbs here. They're going to get down to their temperature, which is just room temperature. And I've got my wet bulb here that I re-soaked in water, in room temperature water, and let it sit for a minute. So I'm basically going to do exactly what we just did upstairs. And it looks like it went to 11. Degrees C. So it only went down by 3. Again, that's a clear indication, once you guys get this down, that it's more humid down here, right? As an aside, not necessarily something that's written in the lab, but let's talk about what that little guy should be doing. Once I turn it back on, I turn it off because it's noisy. It's a dehumidifier. They're generally happier when it's a little bit warmer. But what they like to do, if you have one of these in your basement, let's think about this in terms of like, it's not just a machine I turn on. It likes to pull in warm air. If it was a little warmer down here, this thing would be working a heck of a lot better. It pulls in warm air and it cools it. And when it cools it, you get condensation. That should make sense at this point in the lab. If not, we really got to like start to digest what we're trying to do here. It is complicated, but if it cools that warm air with humidity in it, you get condensation on those coils, and then that just drips down into this bucket. So that's why you got to go take the bucket outside and dump it every couple days, every week, whatever it takes in your basement. Okay, it cools the air down to the dew point, making condensation happen. It's a condensation machine, essentially. All right. So let's pause, go back upstairs, talk about wrapping this thing up, and turn the dehumidifier back on. All right, last part. We'll go sit in front of the fire to wrap this lab up and think about what we're doing here. Both to warm up after that cold basement and to prove a point and to help you answer this question. So, not this question because I don't have a sauna or a steam bath, but if you've ever been in one of those, which is a nightmare in my world, I hate them. What would happen if you were to try to do that Sling Cyclometer if it was already 100% relative humidity? Think about what would happen with evaporation. Does that take place? All right, here's the hard question. And I do want to see multiple of these ideas. This question might take you a few minutes to think about and to answer, okay? So we've got air outside in the wintertime. You can tell because the leaves are gone, right? With my crappy clip art that I found on the internet. And then you've got indoor with a fireplace. Something that a lot of you are probably doing right now. So why is it so dry indoors in winter? You might notice that you've got to put on like moisturizer more often. You might notice that your back gets itchy it's just like your skin gets very dry in the wintertime. If we were to do like little experiments and leave a cup of water out and then try to do that again in the summer, it would evaporate a lot more quickly now. So why is it, thinking about the ideas in this lab, that it is so dry? Like mathematically, why is it so dry indoors in winter? What are we doing to the air? So what an infographic would be is like, here's a picture with little arrows and words that describe the answer that we're trying to get to, right? Rather than writing a paragraph, people find these a little bit more interesting. So you can write, okay, there's cold air out here. We know that, right? So what happens when you pull that cold air in? What's the humidity like outside? What's the dew point outside? What's the like relative humidity outside? And then what happens when you take that air, pull it inside, and just add heat? You just bring the temperature up. What does that do to relative humidity and dew point inside? What would happen to the difference between a wet bulb and dry bulb? What would happen to how much you've got to bring the temperature down to get to the dew point? There's some complicated ideas out there. You might have to like rewatch parts of this video, think about some of the things you've done. This is like a potentially challenging question. It's not going to be, and you are going to have questions that are like, okay, here's a Regents question with 1 point. You get to the answer. It takes you a minute and you're done, right? This is going to be more, put some time into it the way you would an essay if we were in an English class. Only you don't have to write as much. You can just do it with some labels and some words and things like that. Okay. All right, so you guys can nail that, do a good job. And again, it's happening here. Outdoors, it's cold. Down in that basement, it's cold and more humid, right? Up here, I'm burning wood to bring the temperature up. It's radiating heat. I turned the fan off so it wasn't so noisy. It's got a fan that would be making some convection help heat the house here in the room. And if I were to be foolish enough to actually touch it, it conducts heat into my hand as well, right? So this thing is working on 3 levels to get this house warmer. It's bringing the temperature up, but I'm not doing anything to add any moisture to the house. So what is going on with all of those levels, and why does that lead to it being dry indoors? You guys got to figure that out. That point will also come into play on this question, thinking about the nature of blue skies versus snow. Now, the only, I guess, maybe tiny leap here would be that if it's more dry outside, that would be the days where we have blue skies. And if it's more humid outside, that would be the days where we tend to have snow. So if you want to, I mean, I could add that in here. You don't have to write this. I'm just saying for the people that are like, oh, I don't know anything about, Mr. Ruff didn't say when it's going to be snowing. I know, but that really is, it's the same question. When is it dry versus when is it humid? How can you tell by looking at this graph? Give me specific dates and times of when it's dry and it's humid. And the only things on this graph are the temperature and the dew point. If you got what we did up there, this question should be fairly straightforward. A couple of straight up relative humidity dew point questions off the reference tables. That's no big deal. I did want to mention this one over here, though. This thing right here is called a station model. Now, we normally learn these. This year being the COVID year where we're all doing stuff online, I haven't done it yet. I'm not sure I'm going to, honestly. I really enjoy teaching them, and students tend to like have an okay time doing these. We do some fun things with them, but it's like all pencil and paper. I think with the Cami, it'd be very difficult to do this. Man, it's toasty. So what the heck are they? This is basically a concise way to report weather data. Now you can still answer this question with a couple of hints I'll give you. When we draw these, the temp always goes in this upper left slot right there. So that's 62. That's the temperature outside. 970 is the pressure. You don't need that for this question, so that's out. The stick is the wind. This would indicate a north wind coming in at 15 knots. North means coming from the north. Don't really need that for this question either. To the left goes present weather. If you want to see more of these, if you look at the reference table, there's I think there's 12 little symbols for present weather. The dot means rain. That could be relevant to this question. And then inside the circle here, how much of that little circle is colored is cloud cover. So So in this case, it's 100%. So it's cloudy out, it's humid, it's raining, and the temperature is 62. With all that info, you should be able to answer that question. And if you've been clicking in with what we're doing here, you should be able to tell me why choice 4 then would be mathematically impossible. Another regions question, a few more regions questions, and I think you're good. All right. Thanks for fighting through. Good job. We will see how time goes on this. We don't need to rush. And if you have any questions, if you're in class, just ask or shoot me an email and we'll figure it out. Hang in there, folks. Good job. We'll catch you soon.